All right, this will be part 2 of lesson 7.2, and let's get right to what the topic is today. Still dealing in right triangle trig, but today we're going to be focusing more on the identities and practicing these identities that we've already looked at, and then we're going to look at a new theorem that will help us in simplifying some trig problems that are going to show up on our homework today. So let's go ahead and talk about this new theorem, and it's called the complementary angle theorem. And in a nutshell, it says that the complements, and remember, complementary angles add up to equal 90 degrees. So 40 degrees would be complementary to 50 degrees, vice versa. So whenever we have complementary angles and we have co-functions of those angles, then we can say that the co-functions of complementary angles are equal to each other. And I gave you some examples here at the bottom of the screen. What makes a co-function? Well, it's pretty simple. If you just think of sine is a co-function with cosine. You literally just put co in front of the trig function and you have the co-function. So here's another tan and cotan, secant and cosecant. You got to be careful. It's not talking about reciprocals. You know, sine's reciprocal is cosecant. Well, these are not co-functions. We're talking about literally putting co in front of a function, and that makes it a co-function. Pretty logical. So in each one of these cases, these functions are equal to each other. They are co-functions, sine and cosine, and the angle measurements are complementary. So we can always state these as being equal to each other. So tangent and cotangent are co-functions. 55 and 35 are complementary. And so these two statements equal each other. Same thing for secant 10 and cosecant 80. Okay, so with that said, we're going to put all of our identities together along with that complementary angle theorem that we just learned. And we're going to use these in this block of problems to help us simplify these expressions. So recall in our previous lesson we derived three identities called the Pythagorean identities, and one of those was this: sine squared theta plus cosine squared theta equals 1. So that's what number 37 is. It's sine squared theta here in this identity just represents some angle measurement. And so we have basically this identity, and according to the identity, whenever we see this, it just equals 1. So that one's pretty easy. My answer for number 37 is going to be 1. Now the goal in these problems will be to simplify, which means we're going to try our best to boil this down to just one trig function. And so in doing so, we're going to have to rewrite, in many cases, rewrite what's given. And typically it's a good strategy. I wouldn't say that it's 100%, but it's a lot. It happens a lot of times where you can just try to convert the functions in terms of sine and or cosine. And if you can do that, or make them the same, or maybe make them into their reciprocals. Okay, so let me show you how that works on number 39. I notice we have sine and then we have cosecant. Well, they just happen to be reciprocals of each other. And so to show your work, I just want you to pick one of them. And what I'm going to do, and this implies multiplication, I'm going to rewrite cosecant as its reciprocal 1 over sine 80. Okay, and so to simplify these, I just multiply them together, and I get sine 80 over itself. which equals 1. Okay, so that's the process that we're going to be following in all of these problems, and it's a good way to help us. The more we use these identities, the more familiar they become. All right, so I see sine and cosine already presented here in this fraction, so I'm going to change tangent into terms of sine and cosine. That's one of our quotient identities. Tangent is sine divided by cosine. So I rewrote tangent so that it basically matches this fraction that's already given. I don't have to do anything to this. And now when you subtract these, you get an answer of 0 for number 41. Okay, it's always a good idea to have consistency with your degree measurements. So either both of these, to make these able to simplify, either they both need to be 52 or they both need to be 38. It really doesn't matter which. Well, this is going to be an application of that theorem we just looked at called the complementary angle theorem. And it says that if sine 38 degrees is the same thing as cosine, its cofunction, 52 degrees. Notice it's a cofunction and it's the complement, and those are equal to each other, so I can substitute cosine 52 in place of sine 38. And now I've gotten these to where they're the same, and it's easy to simplify them. When I subtract, I just get 0. All right, so I can't do anything until I get the same degree measurement. So either I need to change this into 80 or this into 10. Either way, it's going to involve the complementary angle theorem. Cosine 10 degrees is the same thing as sine 80 degrees. So I'll just go this way. You could have changed sine 80 into cosine 10. And now I'm dividing a trig function by itself, and that equals 1. Okay, same problem here. I've got 20 degrees and I've got 70 degrees. In order to put them together, I need to make them the same degree measurement. So cosine squared 20 is the same thing as sine squared 70. All right, the cofunction and the complement. Okay, now that they're the same degree measurements, I can work with one of my Pythagorean identities, because in those Pythagorean identities, like sine squared theta plus cosine squared theta equals 1, this means that this has to be the same degree measurement. If it's not, I can't, that identity is not useful. Well, now I've changed this so that they are the same. And sometimes it's good to start with what we might call this basic identity, but we can come up with other variations of that that also end up being useful in simplifying. Like, for example, all I did here to this initial identity was subtract sine squared from both sides. Well, this is still true. Cosine squared theta is equal to 1 minus sine squared theta. And if that's true, then that means I can substitute 1 minus sine squared 70 with cosine squared 70. I just made a equivalent statement, started with this basic identity that we derived, and sometimes you'll do the same thing. It'll be helpful to solve for sine squared, subtracting cosine squared from both sides. So those are kind of things that you learn the more you do these identity problems. So now we've set this up to where it's easy to simplify. Those two subtract, and we end up with an answer of 0. All right, this is all multiplication, so the only problem is I've got two different degree measurements, and I think it's helpful, if you can, to change everything in terms of sine and cosine. Well, fortunately for tangent, that is sine over cosine. So I just rewrote tangent in terms of sine and cosine. This one is kind of the oddball. It's the only one that doesn't have a 35 degree. So let's change it using the complementary angle theorem. So secant 55 is the same thing as cosecant 35. And cosecant is 1 over sine. All right, so we're in the process of making everything in terms of sine and cosine, and we change the degrees to where they all match. And now, since we're multiplying, we can do some canceling. I can cancel this way. I can cancel these. They're diagonally across from each other. So my final answer is just 1. All right, we are ready to move on to another example. So kind of the same problem. We need to convert into the same degree measurement. So it really doesn't matter which one you go. Sine 35 is the same thing as cosine 35 is the same thing as sine 55. Complementary angle theorem. And then I need to stay with 55. That it's going to be the degree I've chosen. So I don't need to change this one, obviously, but sine 35 is the same thing as cosine 55, complementary angle theorem. When you multiply these together, this is sine squared 55, and this is cosine squared 55. And that should look familiar by now. We have a Pythagorean identity that looks like this, that sine squared. Now this represents the same angle measurement, and they are the same. So anytime you add sine squared theta and cosine squared theta, you get 1. So my answer for number 53 is 1. Okay, when you get down to the bottom of the page, the problems are going to change a little bit, and they look like this. They're going to give you one trig value, and then you're going to use that and identities to find the other 4. Okay, well, this says sine 30 is 1/2, and we're asked to find cosine 60. Well, remember that theorem, the complementary angle theorem, says that sine of an angle is the same thing as cosine of the complement of that angle. So sine 30 is equal to cosine 60. And if sine 30, of course, is 1/2, then so is cosine 60. All right, letter B. We have this identity. Whenever you see a trig function squared, it typically means that you're going to be using one of the Pythagorean identities. And since I noticed cosine squared is in this problem, I'm thinking about this identity. They tell us that cosine squared is 30 degrees, so I can go ahead and put 30 degrees in place of the cosine squared. Sorry, that should be cosine squared 30. All right, and this is sine squared 30. We know that the angle measurement has to be 30 degrees. All right, so we know what sine squared or sine 30 is. We're given that. So if sine 30 is 1/2, then sine squared 30 is 1/2 squared, which is 1/4. And now we're just going to solve for cosine squared 30 by subtracting 1/4 from both sides. And 1 minus 1/4 is 3/4. And so since they just wanted cosine squared, not cosine, I don't have to do the square root. That is my final answer. Well, remember, this is in radians, but in degrees, this would be 30 degrees. Pi over 6 is 30 degrees. So cosecant is the reciprocal for sine. So if sine 30 is 1/2, cosecant, which is the reciprocal of sine, has to be 2. So sine 30 is the reciprocal, cosecant 30 is the reciprocal for sine 30. So my answer for letter C is just 2. All right, and then this is the radian degree measure for 60 degrees. And secant is the reciprocal of cosine. So kind of the same deal. We know what cosine 60 is, that's 1/2. And since this is a reciprocal, secant 60 has to be the reciprocal of 1/2, which is 2. Okay, I think that takes care of it. That gives you some examples of what you're going to be doing on your assignment. And I hope that helps you out. If you have any questions, let me know.